Welcome back, Geometry, one more time. In this video, we'll be going over some tougher standard level problems, so definitely take out a writing utensil and definitely something to write with, and maybe some colors because they'll probably be helpful to you. And let's go ahead and get started. Okay, so let's take a look at the instructions. So they tell us to determine the values of x, y, and each angle in the diagram shown. So let's go ahead and start tackling diagram A. So when I look at this diagram, I can see that the angles that I'm highlighting, or not the angles, the lines that I'm highlighting in yellow are parallel, and I know that because of this arrow here. Okay, so if these lines are parallel, then I've really got two different transversals. One transversal is shown here. So let's just look at that one. Let's just focus in on this side of the diagram with the 90 and the 3y plus 18. So if we're looking at this angle, and then this transversal, well, I can see that the 90 and the 3y plus 18, those are same side interior angles. Now, same side interior angles are supplementary. So if they're supplementary, that means when I add them together, they're going to give me 180 degrees, and that's how I'm going to solve for y right there. So I've set up my equation, and the next thing I want to do is solve for y. So I've got 3y, and I'm going to combine the 18 and the 90 to give me 108 equals 180. And then to solve for y, I want to subtract 108 on both sides, and I get 3y equals 72. And then my last step is going to be to divide by 3. So y in this diagram is equal to 24. And when I plug that into the expression, I'm going to get that this is also 90 degrees. And oh, look at that. If two lines intersect to make a 90-degree angle, that means that they are perpendicular to each other. So I'm going to put a little box here and a little box here to show that they are perpendicular. Okay, now let's focus in on the other side of the diagram. So again, I've got my parallel lines, and this time this is going to be my transversal. Same concept. Those two angles, 15x plus 30 and the 10x, those are same side interior angles, which means that they are supplementary. So I'm going to do 15x plus 30 plus 10x and set them equal to 180. Let's combine any like terms. So I get 25x plus 30 equals 180. Subtract 30 on both sides. I get 25x equals 150. Divide by 25, divide by 25. And 150 divided by 25 is going to give us 6. So here, x equals 6. Okay, let's go ahead and plug this in. So let's see, that means this angle would be 60 degrees. And I can plug 6 into the other expression, the 15x plus 30. And when I solve for that, I should get 120. Or I can just do 180 minus 60, since I know those two angles are supplementary. Okay, let's move on to the next diagram. We've got something a little trickier here. This time, I've got these two parallel lines and a diagonal transversal here. Okay, so if I'm looking at those two parallel lines, I see that I've got a pair of alternate interior angles. They're in between the parallel lines, and they're on either side of the transversal. Alternate interior angles are congruent. So if they're congruent, I can set those expressions equal to each other and solve. I'm going to subtract 5x on both sides, and I get negative 2x equals negative 20. Divide by negative 2, divide by negative 2, and we get that x equals 10. So if I substitute that in, that would mean that this angle is 30 degrees, and this angle is also 30 degrees. Okay, next I want to solve for y. Well, when I look at my diagram, I see that I've got a triangle here. And I know angles of a triangle add up to 180 degrees. So another equation I can set up is 2y plus 4y plus 30 degrees equals 180. all I'm doing is adding all of the angles of the triangle and setting it equal to 180. So I get 6y plus 30 equals 180. Minus 30, minus 30, and I get that 6y equals 150. Whoops. Divide both sides by 6, and 150 divided by 6 equals 25. So I get y equals 25. And if I substitute that value in, that would mean that this angle is 50 degrees. And this angle is 100 degrees. Okay, and now I've answered that question. Let's go ahead and do the last one. So this one, our pair of parallel lines just looks a little differently, but it's actually our easiest picture because it's literally just a pair of parallel lines and a transversal. So when I look at the 9x plus 12, I can see that it's going to be congruent to the 4y minus 10 because they are alternate exterior angles. So I'm going to do 9x plus 12 equals 4y minus 10, and that's one equation. And now that I look at it, I can see that I'm going to have a system. Okay, so that's one equation. I need another equation. Let's see how we can relate this 3x. Well, 3x and the 4y minus 10, those create a straight line, which means they create a straight angle, and straight angles are 180 degrees. So another equation I can set up is 4y minus 10 equals 3x. Okay, the next thing I want to do is move all of my variables to one side and all of my numbers to the other side because I think I want to use elimination to solve this system. So I'm going to subtract 3x, and I get negative 3x plus 4y minus 10 equals 0 because 3x minus 3x is 0. Okay, I want to move the 10 to the other side, all of my numbers on the other side. So I get negative 3x plus 4y equals 10. Okay, so I've moved all of my variables to one side and the numbers on the other side. I'm done messing with that equation. Let's look at the gray one. So similar idea. I want to move all of my variables to one side, so I'm going to subtract 4y. So I get 9x plus 12 minus 4y equals negative 10. Okay, I want to subtract 12 because I want all of my numbers on one side. And I get 9x minus 4y equals negative 10 minus 12. That's going to be negative 22. Okay, so now I've got all of my variables on one side, and I'm done messing with that gray equation. Next thing I want to do is to stack my variables, and I'm going to do that over here. So I'm going to do 9x minus 4y equals negative 22. And I'm going to write the green equation right below it. I have negative 3x plus 4y equals 10. So if I want to use elimination, I want to eliminate one of my variables. When I look at my y's, I can see that the numbers in front, aka the coefficients, are the same. Whoops. Because they both have a 4 in front of the y's. So I don't really need to alter any of my equations. I can just go ahead and add the top equation to the bottom equation because when I add negative 4y plus 4y, that cancels out. And then we can do the rest. So we have 9x plus negative 3x, that becomes 6x. And negative 22 plus 10 is going to be negative 12. Let's divide by 6 on both sides, and we get an answer of x equals negative 2. All right, we've solved for x, but we haven't really solved for y, so we need to go ahead and do that. We can plug it into either equation. I'm going to plug it into the green equation, so negative 3, and instead of writing x, I'm going to plug negative 2 in, plus 4y equals 10. And then I just want to multiply negative 3 and negative 2, so that gives us 6, plus 4y equals 10. Subtract 6, and we get that 4y equals negative 4. Divide both sides by 4. I'm sorry, that shouldn't be a negative 4. That's a positive 4. 10 minus 6 is just 4. And 4 divided by 4, that's going to give us 1. So x equals 2 and y equals 1. And then we can just go ahead and plug those values in and figure out what the rest of the angles are. Okay, thanks for watching.